Hi class, welcome again to another session on digital principles and system design. So moving on to the fourth unit, let us start discussing asynchronous sequential circuits. So we start off with the introduction. So an asynchronous sequential circuit is a circuit where change in the output occurs due to change in the input variables. So these circuits are not synchronized with a global clock signal, and the memory elements in such circuits are unclocked flip-flops, also called as latches or time-delayed memory elements. So if we see a typical block diagram of an asynchronous circuit, then you have a combinational circuit and part of the output is fed in as another input to your combinational circuit. So this is through the feedback. So the design of an asynchronous circuit is often very challenging because of the time delay of the feedback mechanism. So too long a delay can also result in catastrophe, and too short a delay will not give you accurate outputs. So it is very tricky to get that balance correct. So like I said, it generally consists of two major blocks, a combinational circuit and a delay element that is connected to the combinational circuit in the form of the feedback. Now in a gate type circuit, that is a circuit that uses logic gate, combinational path from the input to the output induces sufficient delay along with the feedback, so there's no extra delay element required. Now how does this delay come? It comes by the delay induced by each and every logic element along with the delay induced by the wires, the connectors. So the present state variables with such circuits are also called as the secondary variables, and the next state ones are also called as the excitation variables. So if we go back to our block diagram, so we have three symbols here. We have the X, we have the capital Y and the small y. So X is my external input, capital Y is my output or excitation variable as far as asynchronous circuit is concerned, and small y is my secondary variable because part of the output is getting fed back as an input to your combinational circuit. So therefore small y is your secondary variables. Now I tried changing the notations for these because capital Y and small y are pretty confusing, but these notations have been followed in literally every digital electronics book that I have referred. And so if I try to change it, I'd probably make things more difficult for you than making it easy. So let us just stick to these variables. So point to note is that your X is your external input, your capital Y is your output, also called as the excitation variable or the next state, right? And your small y is also called the feedback or your secondary variables or the present state. So these are the terms that you need to nail in your brain while you are dealing with asynchronous circuits. Now when X changes, that is your input changes, Y, small y or your secondary variable or the feedback does not change instantaneously because let's take a points, right? So when X is changing, when X changes, right? So this combinational circuit, which consists of various gates, each logic gate would take some time to process the input, and finally after a certain nanoseconds Y will appear, capital Y, which is your output or your next state. Now part of this Y is also getting fed as an input, so there is a delay induced by your combinational circuit. Therefore as soon as your X changes, your Y, small y is not going to change. Capital Y will change after certain delay, and small y will change as soon as after capital Y changes, and then a few nanoseconds later the small y will also change because there's input, there's delay everywhere in this circuit. So there are two conditions for your asynchronous circuit because it is not controlled or synchronized with clock signals. There are two conditions that an asynchronous circuit keeps on toggling. These are the steady state condition or the steady state circuit is like a steady state, and the transition state or transient state, right? So when both your secondary variable and your excitation variable are the same, that is your small y and capital Y are equal, then that condition is called as the steady state. However, during transition state, these are not equal, right? So transition state from one steady state to another occurs only with response to change in input variable. So if there is no change in input variable and there is an equilibrium in the system, then that equilibrium is not disturbed till the input changes. And this is one of the major difference between the synchronous and asynchronous circuits, because in latter, every time the change in state is governed by the presence of clock pulse. However, in asynchronous circuit, the change in state occurs with change in the input variable. Therefore, to ensure that the operation of an asynchronous circuit is proper, right, only the circuit is allowed to get stable first. That is, small y becomes equal to capital Y first before any other change in input occurs, right? Because the delay, and this is very, very tricky because there's quite a lot of delay induced because of the components, right? So we have to make sure that we have a method to calculate the delay and then set a feedback accordingly, right? So one more prerequisite for an asynchronous circuit is that you have to make sure that at any particular interval only one variable change. I know all this does not make much sense to you at the moment, but when we see an example, I'm sure you'll be able to understand this better. So now the circuit should be designed in such a way that only one variable changes at a particular instance, and the duration between the change in the input should be sufficiently large to allow the system to become stable before another change in input occurs. Alright, so a larger delay will ensure that the system enters the stable state before accepting a change in input. Now, this mode of operation is also called as a fundamental mode, where the system allows change in input variable one at a time. So moving on to the analysis procedure. So analysis of a synchronous circuit involves representation of the circuit in the form of a table or a diagram that completely summarizes the operation of the system or the circuit. So a logic diagram is considered an asynchronous circuit if it has a feedback loop or if it includes unclocked flip-flops or latches. Okay. So one of the basic methods of analyzing an asynchronous circuit is using a transition table. You also have other methods such as using the flow diagram or using the stability analysis method. But I think for our course, transition table should be sufficient. So in the subsequent video, I shall discuss more about how to use transition table to analyze an asynchronous circuit. I hope you take care till then. I shall see you again in another video.